So continuing this discussion of graphs of functions, I'd like you to pause the video and try example number 2 on your own. Okay, the graph, this is the graph of a function g. Like, just pause the video and work on this, and then we'll go over the answers. Okay, so we can see in this case g of negative, we'll just look at the corresponding points where the x-coordinates are in the parentheses. So we see that -3 corresponds to 1. Okay, we can see g of 0, it's the y-coordinate. Again, that is 2. When the x-coordinate is 3, the y-coordinate is 0. When the x-coordinate is 4, the y-coordinate is -3. So we have that. Okay, what's the domain? That corresponds to the x-coordinates. And it looks like it goes from -3 to 4. But we can see that at 2, there's a vertical asymptote. Okay, there is no point on the graph whose x-coordinate is 2. So we have to exclude 2 from this. Okay, so this we can write, so it's all the numbers from between -3 and 4 except for 2. And we can represent that in interval notation. We can say negative square bracket -3, 2, union, round bracket 2, and then 4. Okay. So that would be the domain. The range corresponds to the y values. Okay. We can see that the lowest point on this graph is at this point where y is -3. And we can see that if we take any horizontal line above -3, it will cross the graph at least once, right? And a couple times it will be twice. Okay, but so basically the y values are all values greater than or equal to -3, which we can denote by this. All right, now the last 3 problems just basically can be rephrased. We ask if g of x equals a number, that means that the graph, there's some point on the graph with a specific y value. And another way of saying it is that the graph will intersect a horizontal line at some point. So when we ask does g of x equals 4 have a solution? We're really asking, are there any points on the graph where the y-coordinate is 4? Okay, well, we can see that 4 is up here. And sure enough, we can see that there are these 2 points here that correspond to that y value. We don't know exactly what the x value is. We know that this one term seems to be between 2 and 3. But we're not asking for the x value. We're not asking for the actual solution. We're just asking, does it have a solution? Okay. And another way of looking at it is, does the graph cross the line y equals 4? And it does. So the answer is yes. Okay. Similarly, at -1, which is down here, it crosses the line at y equals -1. So it's this point. Again, it looks like it's between 3 and 4, but we don't really know for sure. But all we know is that it does have a solution. And does g of x equal -5? Does that have a solution? Well, clearly not, because -5 is all the way down here. Okay, and we can see the graph stops at this point. So there is no point where the y-coordinate is -5. So the answer is no. All right, let's look at the last example, example 3. Okay, here I don't give you the graph, but I ask some questions about the graph. First question is the point -1, 1 on the graph of h? Okay, well, another way of asking is if the only way it can be on the graph of h is h of -1 equal to 1? Okay, well, we can check. H of -1 is going to be -2 times -1 squared plus 3 times -1. Okay. And we can see that this is going to be negative 2 times 1 plus negative 3. That's negative 5, which is not equal to 1. Okay, so the answer is no. Similarly, you can check that, so if is 2 negative 2 on the graph? Well, we look and see what is h of 2. And if you compute h of 2, this turns out to be, well, I'll go through it. This is negative 2 times 2 squared plus 3 times 2. This is negative 8 plus 6, which is 2, which is negative 2. Right? So that is what it's supposed to be. So the answer is yes. Okay. The x-intercepts of the graph of h. Well, basically we want to know, so if the x-intercept, the y coordinate is 0, so that means h of x is going to be 0. All right, so we set h of x equals 0, and that means we're setting minus 2x squared plus 3x equals 0. All right, now we'll talk about how to solve quadratic equations in more general in a little bit later. But right now, we can see that we can factor out an x. Factoring is going to be a good way to solve equations like this, especially with if every term has an x in it. So we can factor out an x, and that leaves us with minus 2x plus 3. Okay, and that means we have this number times this number is 0, so one of these has to be 0. So either x equals 0 or minus 2x plus 3 equals 0. And that means that 3 would have to be 2x, and x would be 3 halves. Okay, so we have two x-intercepts, one at 0 and one at 3 halves. The y-intercept, well, y-intercept, that means x is 0, so the value of the y-intercept is just h of 0, which we can check that that's 0. So it's going to be y equals 0. We sort of knew that because we already know that if the x-intercept is at the origin, then that's also going to be a y-intercept. The domain, we can plug any number we want to in here. We'll get another number. So the domain is all real numbers. And the last question asks, does the graph cross the line y equals negative 9? Okay. Well, if it does, that means that there's going to be at least one point on the graph where h of x equals negative 9. So we basically want to solve for this equation, h of x equals negative 9. And so that means we have to set this equation, negative 2x squared plus 3x equals negative 9. We can add 9 to both sides, and we get and change the sign, and what we'll get is 2x squared minus 3x plus 9 equals 0. And we could use the quadratic formula, which we'll talk about later, or we can just factor this. This factors as 2x plus 3 times x minus 3 equals 0. And I don't have room to finish this, but if you set 2x plus 3 equals 0, you get x equals negative 3 halves. And if you set x equal to x minus 3 equals 0, you get x equals 3. So not only do you get one solution, you get two solutions. So the answer is yes.